Good evening. I know it has been a long day, but I hope it is full of learning, new perspectives. I think you would have learned a lot about new tools. Just like Avinash, I'm not here to sell anything. I don't have a product. I'm going to talk about the digital transformation journey of my business, which is Grasim. We are a part of Aditya Birla Group. Um, That's something about me. I've spent about 15 years now with the group. Before that, I was with Shell for some time, 3 businesses in Shell, and some time with Bunge, which is one of the largest edible oil producers. This is the agenda that I'll talk about. Uh, Very simple, no tech jargons, because it's all about business. How a business functions and how we are using technology to leverage and improve quality. How many of you have heard about something called as pulp and fiber? Okay, great. I think we have some, generally I end up in a session where people have not heard about pulp and fiber. So fiber is the core business that we have. Since fiber manufacturing needs a lot of, or the raw material is pulp, ABG decided to acquire a few pulp mills. That is how this business got changed from fiber manufacturer to pulp and fiber. So if you look at the journey of Grasim, we started the foundation, or the foundation stone was laid the year we got independence. So it's a pretty legacy business. It's a core traditional manufacturing business. Nagda, which is our first unit, that was operational sometime in 1954. And if you visit Nagda today, it is all about ABG. So just like you have Jamshedpur, Tata Nagar, which is all about Tata Steel, Nagda is all about Birla. So the side where our manufacturing facility is known as Birla Gram. Over the years, we started setting up plants overseas. So we were probably one of the earliest Indian multinationals to have a base in India and expand overseas. And that is one of the, whenever anybody joins after working in a multinational company, the best part of Aditya Birla Group is we are the one here in India who make decisions. People in Canada, Thailand, Sweden, they follow the decisions that we make. So that's the fun of working with ABG. When I joined ABG, I never thought I'll be here for so long, but it's an amazing place to work. So when I'm talking about amazing place to work, it is not only amazing place to work, but all these locations that you see, ABG will have a school there. It will have a hospital. It will do a lot of things for the community. So they take care of the entire ecosystem in these places. These are very small manufacturing locations. So this is all about manufacturing, except the last line, which is Navyasa. You must have heard about Navyasa, which is our foray into B2C. Navyasa is the sari brand that we went live with about a year back. We have one retail outlet here in Orion Mall, right? So Liva was a very popular brand among the women. So to capitalize the brand presence, we used that and we came up with a sari business. This is our global presence. We do have marketing offices and R&D centers at places where we don't have our plants. So here we will start talking about the digital transformation. So I think Avinash showed some 4 steps of transformation. Here we have used a 3-step approach: digitize, digitalize, and digital transformation. So in this, what we are doing is, as I said, since we come from a very traditional manufacturing organization, a lot of our processes were manual processes. Logbooks were being used. Uh, a lot of papers were there. So there was a lot of scope to digitize those. So digitize is a step where we are saying providing visibility. So dashboards, you have historians which is collecting production data. So how can that data be shown at the shop floor? So we did a lot of initiatives in the digitize, and we call it as breaking the 80-20 rule. So which means earlier, people will spend 80% of the time trying to get data and 20% of time to analyze the data. Today, we are saying you need to spend 20% of time just to get data, and you have all the time to analyze the data. So that will help you with better decision making. So that is a digitized story. Today, I would say some of our plants, we have very mature digitized story. So we have a lot of data which is available as a part of the digital form. Second is digitalize. Now the difference between digitize and digitalize is, in digitize, you've acquired data. Digitalize, you're using that data. You're using that data to make decisions. You're using that data to give some inputs to the operators on how to run a power plant, how to run the production. So this is where we are using analytics, correlation, using things called as soft sensors. Most of the predictions, all of them are here in the digitalize. And finally, we talk about digital transformation, which is more of a program. It's a long-term program where the step 1 and 2, you use the data, you use the analytics models, and then have a connected enterprise. One example here, which I would like to talk about, is something called as Green Track, which is our own blockchain story. This was probably the first of its kind in this industry. First of all, we don't have too many competitors. In India, we don't have a single competitor. Globally, we have an Austrian firm, Lenzing, which is our global competitor, and there are some in China. So we don't have established set of rules or established set of SOPs. We have to create our own. So in the Green Track platform, we were the first one to come up with a platform which will give you visibility across the value chain. So when I talk about value chain, we are manufacturing fiber. We also manufacture pulp. Pulp is used for fiber manufacturing. And from there, it goes into the value chain where we don't have any visibility. Who are our end customers? End customers are brands. H&M, Marks and Spencers. So the garments that you're wearing, in all likelihood, it may be a Grasim fiber that is gone into manufacturing that. So, but we are not present there. That you buy through a H&M or any of those brands. So the brands in Europe, they are very conscious about sustainability. So which means they want to know, while manufacturing this garment, have any of the value chain partners followed or not followed the sustainable practices. So what we do is, we have a blockchain-based solution which gives you traceability at both the sides. So the brand wants traceability, so the brand gets a QR code which is printed along with the garment. So you scan the QR code, you get the entire traceability that the pulp came from Canada, it went to Indonesia. In Indonesia, the fiber was manufactured. From there, it went to a spinner somewhere in Thailand. From there, it went to a garmenter in Bangladesh, where the garment was stitched. And from there, it is in a store in, say, Italy. So the entire visibility is what is given by the Green Track program. So this is one of our story on transformation. We have a lot more which we are working towards. Now I'll talk about core manufacturing. So in manufacturing, these are some of the areas where we have used AI. The first one, quality control and inspection. So, see, for using AI, you need the data. Now, data can be either through the data which is acquired through sensors or historians. Second is data can be a data which is seen live using video, right? So here, what we are talking about is vision analytics, where you can. So first vision analytics use case we went live with was way back in 2018 odd, where we use the video analytics for safety, whether PPs were being worn in the factory, vehicle movement, whether it was happening correctly or not. So a lot of such safety use cases we started, and then we moved to quality. So today, we have at least 5 or 6 AI-based vision analytics use cases that we are using in our manufacturing. To name a few, when the fiber is manufactured, there has to be a specific level of whiteness that it has to have. So we've put cameras at the conveyor to see whether the whiteness is as per the customer expectation or not. Second is, while manufacturing fiber, there can be black spots, yellow spots. So again, these cameras are detecting that. So these are some of the examples of vision analytics in the manufacturing process. Second is inspection. Again, for inspection, we see, for our industry, as I said, there are no solutions which are readily available. So we have to identify partners who can co-create such solutions with us. So we had a very specific requirement of doing some inspection of equipment which is used in our core process. So we worked with a Bangalore-based startup, and using, again, vision analytics and a bit of AI, that is the kind of solution that we have implemented. And we tried it in one of our plants, and today it is across all our plants it has been implemented. Digital twin, I think this was a buzzword some time back. Everybody talking about digital twin. So digital twin can be about either the process or it can be about the assets. So we have digital twins for power consuming equipments like chillers, air compressors, which are used in the utility side of the plant. And we also have a few digital twins for the process side, wherein you see what is the kind of input that is going in and can you control the output. The other complexity in our process is that we have both the processes. We start with a batch process and then it moves into a continuous process. So getting this end-to-end traceability or control over the process is very difficult. You don't have a source where you can see the end-to-end parameters. You have one area where you will get the process. You will have the pulp section, which is completely isolated from the rest of the manufacturing process. So that is why there is a lot of complexity in using any kind of technology, AI technology in our process. So we are identifying assets or processes, trying to do a digital twin of that. The plan is that maybe once we, say after a couple of years, we may have the digital twin of our end-to-end process by doing in small bits. Maintenance and process optimization. This is a very common area in manufacturing where analytics is used. Predictive maintenance, prescriptive maintenance. So you're using the data which is available and you are having models which will tell you whether the asset is due for maintenance, whether the asset you can use it for another 15 days, 20 days. See, what it gives you is you're moving away from something called as preventive maintenance. So earlier, if an equipment had to be we wanted to ensure that it doesn't break down, so you do a preventive maintenance. Say after every 30 days, the asset has to go undergo preventive maintenance. Whether it needs that or no, but as a SOP, you do it. So which means you have to stop the machine, you have to halt the production, and it is a process in itself. So what preventive maintenance does, or what predictive maintenance does, is that you don't have to do a scheduled stoppage. The models will tell you it is due for maintenance. You can take a call and then stop the plant. So this helps in a better uptime and better profitability of the manufacturing facility. And similarly, prescriptive is a step ahead where the models will tell you that this roller will fail after so and so time. So it is not talking about the asset, it is talking about in the asset what may go wrong. So for that, again, you need some more amount of data maturity is needed. Process optimization, so I spoke about something called as soft sensors, wherein physical sensors are which you mount on the equipment. You have a pump on which you put a sensor. It will tell you what is the RPM, what is the heat generated, and some of the parameters that will help you decide the health of the equipment. Soft sensors is where you have data in a historian, the process data. You're using that process data. You're comparing that with traditional 6 months of data, and you're building models to say that if this is going to be my process parameter, this will be the output. So it takes time to stabilize a soft sensor because it's all about playing with the data that is available to you. Power plant is another area, energy, you have coal, you have a lot of high cost elements being used in a power plant. AI, you can use AI to say that what kind of coal should be used to get this kind of output of the power plant. A lot of use cases are there. So one is using AI, the other is using things like APC, which is process controls. Genealogy is something where, so we manufacture bales, 250 kg fiber bale is what the output is. Now, how do you identify that if this bale, after it goes to the customer, if the customer has raised a complaint, you never knew that there was a problem, but it has not performed at the customer side. So the customer has raised a complaint. Now you have to go and trace back as to what was the problem with that bale. So for which we use product genealogy. It is mapping the output bale-wise to the process parameters. And you can identify what went wrong if there was something wrong. If there was nothing wrong, then probably there's something wrong at the customer side due to which the fiber is not performing the way it should perform. And finally, customer centricity. So here we spoke about blockchain-based solutions. So that is actually a solution which the customers have appreciated a lot. And similarly, there are a lot of other models which can help us with the customer centricity. Moving on to the supply chain. Supply chain is a very standard use case for AI. I'll not talk much about it, but you can use the past data to do demand forecast. You can use the past data to do route optimization. Lot of use cases. And the last two are more about customer engagement in terms of having chatbots and interfaces where the customer gets real-time information. And again, in the supply chain, you have the raw material coming in, you have the goods being dispatched to the end customers. How can you leverage, if I am doing some export consignment, can I use the same containers which came to give me the raw material? Can I use the same containers to dispatch my outbound? So there are a lot of areas where AI can be used for optimization, and we have started our journey. We have a few use cases where AI is being used. So this is a very important point which I thought we'll spend some time on, which is the people. I think technology companies, B2C, so here the type of people that you have are completely different. In a manufacturing setup, just imagine a plant like Nagda, which is such a legacy plant. The average age of people working there would be in the 50s. And they would have been working there in the same plant as the first job, and they'll retire from there. So that is where we face a lot of legacy mindset, resistance to change. They have been doing something in a particular way for years. Now, if we go and say that here is a tool, it will help you to take decisions. The first thing that they'll say is, please go. I know how to run this machine. Looking at the machine, I can tell when it will fail. So that's the mindset that we have to change. We just take very small steps of giving them a tool to play around, just to see that. See, the other thing that is there in their mind is whether this will take away my job, right? So we give them a tool. We tell them that this will help you with your decision making, and we have seen mixed success. In some of the projects, we see that people accept these new technologies. In some cases, they find 100 reasons why not to use that. So our approach is, okay, in this plant, it's not working, let's go to a new plant. And once it is established in any of the manufacturing plant, then it's all about replication. If it works in one place, it has to work in the other plants as well. I was reading about a research which was done, and somewhere in 2019-20, it was said that in the next 15 years, AI and similar technologies will probably eliminate 14% of the jobs, and it will change around 32% of the jobs. So this means globally, around billions of people, their skills are at stake, or their jobs are at stake. So organizations like ours, what they do, or maybe even I think Kiran spoke about Hindalco following an approach of digital champions, upskilling. So here we talk about reskilling and upskilling. So which means, as an organization, we identify a digital capability building program. We are running a digital capability building program wherein the operators, they are taught on new technologies, how to use new technologies, how to, say, do some models using Python or any of those tools. So we take them, we have batches, and we try to reskill them, because see, as I said, this is more about community as well. It is not about running a business. It is to ensure that people have jobs, and technology doesn't take away the jobs. So that is the reason why, if you see, this is a very important aspect in, at least in manufacturing. I think in terms of technology companies, your shift is around 2.5 years. Your skills get outdated. So there a completely different approach has to be taken, which I think the leadership there would be taking. This is my last slide. This is all about how digital transformation is, as a program, is driven in a manufacturing organization. So it's first is business as usual. So when we started our digital transformation, when we take any program to the leadership, you are getting profits, you are the monopoly in the country, we don't need to do this, right? So there was no buy-in from the leadership. So what the next step is, you do present and active, which means you start running small programs, do some pilots, some POCs. Then once you start seeing the output of that, that is where you formalize those. So you form teams. There is somebody from the production, somebody from supply chain, that they will be a part of that, because somebody has seen value in the pilots that we are doing. Then you have a more strategic and converged direction for digital transformation. So this is where you have a digital transformation team being set up, people working with very fixed goals. I think goals, uh, I, for me, I know that in Aditya Birla Group, some of the businesses have goals that they want digital to contribute or to sort of save 5% of their EBITDA. That's a very aggressive target to take using digital tools. But some of our businesses within the group itself have taken those targets, and we are also in the process of saying that what will be the end goal, where the whole digital journey will end. That's it that I had. Any questions? Sure.
Thanks, Vinay, for the presentation. I was just looking about on the revolutionizing on your supply chain resilience. If you can go back to that slide, if you don't mind. Yeah. So, like I have a couple of questions. This are the technologies which is more on the location-based services, right? Like when you're saying dynamic routing, real-time analysis, personalizing customer engagement. So do you have your in-house team, or you involve, or you take help from the other third-party vendors or something like that?
Yeah. We don't have an in-house team,
Okay.
but what we have is, as a part of the Aditya Birla Group, there is a central data analytics team based in Bangalore. So they work with the vendors and they do value addition on top of that. So while we may engage auto plant or some of those vendors to give us those solutions, but the data analytics team, they will do value addition on top of that and give us the intelligence that is needed.
They will create, the outside party will create the structure, whereas the real meat will be added by your data analytics team.
Yes.
That's what you're saying.
Yes.
Okay. Thank you for that.
I don't think there are any.
Hi, Vinay. Nice session. One question. Did you have a use case with regards to the rejection of, reducing the rejection?
Yeah, so the use case where I spoke about the whiteness and fault detection, so that goes to, so the faults we don't come to know during production, because the bale just gets, it's a 250 kg bale, so the yellow patches can be somewhere in between. So it goes to the customer, and we come to know after it has been delivered to the customer that there is a problem. So then that is a reject bale for us. So here we are actually in real time, we are identifying whether there is a problem with the bale, whether the whiteness is as per the customer expectation or not. So this has reduced us to, help us to reduce the
So on that itself, so then were you able to identify that during the process or towards the end?
Yeah. So as of now, it is during the process. Sorry, during the process as in during the conveyor, when the fiber is moving, so we are still not able to identify the root cause of that, because as I said, we don't have visibility end to end in the process. We are running some programs to get the pulp side of data and then integrate that with the fiber process. Maybe in a year's time, we should be able to get that. Yeah. Thanks. Thank you.